Hello guys, pre-processing data. So in this tutorial we will read about how we will process our input data for further processing. Now artificial intelligence algorithm expect data to be formatted in a certain way before they start the training process. So we know that when we are using any algorithm, then it is the basic requirement that our input data must be in a format way, or you can say the data must be formatted. So for that, we need some pre-processing. In order to prepare the data for ingestion by artificial intelligence algorithm, we have to pre-process it and convert it into the right format. So basically what is pre-processing? We have to convert our data set into the correct format so that it can be used further. Okay, now what are the different ways by which we can pre-process our data? So these are your different ways: binarization, mean removal, scaling, and normalization. Now first, what is binarization? This process is used when we want to convert our numerical values into Boolean values. Now, this process is used when we want to convert our values, our numerical values into Boolean values. Now, you know very well that what is Boolean. Boolean is either true or false, or you can say either 0 or 1. So, for that, we are using pre-processing module, which is your inbuilt module of sklearn. Sklearn, that is your scikit-learn module, and binarizer is your function present in that pre-processing module, and we are passing here an argument threshold that is of integer type. So this is the function which we will use for binarization, or you can say for binarizing our input values. Next, mean removal. It's usually useful to remove the mean from our feature vector so that each feature is centered on 0. Now what is feature vector? So vector, you can say that a list. So that list will contain our features, different features. So what we are doing here, we have to remove the mean from our feature vector so that each feature will be centered on 0. For that, we are using the function scale function of pre-processing module, and then we are passing input data as an argument. Next, scaling. In our feature vector, the value of each feature can vary between many random values. So it becomes important to scale those features so that it is a level playing field for the artificial intelligence algorithm to train on. Now basically what we are doing here, in our feature vector, the values of each feature can vary between many random values. There can be different values for each feature. So basically we are scaling those features, and for that we are using min max scaler function of pre-processing module. Next is normalization. Now we use the process of normalization to modify the values in the feature vector so that we can measure them on a common scale. So basically we are modifying our input values so that we can measure them on a common scale. That is, we can use a common scale for measuring them. That is your normalization process. Now there are two different types of normalization process: Alvin normalization and L2 normalization. Alvin normalization means least absolute deviation. Works by making sure that the sum of absolute value is 1 in each row. And in case of L2 normalization, that is your least square, works by making sure that the sum of square is 1 in each row. Now let's perform these processing on data using an example in Python. Now we are seeing a program in which we are doing these processes. We are applying these processes on our input data. Okay, so let's see a program in Python for pre-processing our data. So for that we are using that program. In this, first we are importing few modules. So these are your NumPy module and your sklearn module, that is your inbuilt module, scikit-learn module, and we are importing here pre-processing module present in that module as a submodule. So first we are taking our input data using array function of NumPy module, and this is your input data. We are taking that data into this variable, input data variable. Next, we are performing our first method of pre-processing data, that is your binarization. Now for binarization, we are using binarizer function that we have seen that function, and we are passing here the threshold value as 2.1, and then we are applying transform function for organizing our data, and then we are taking those binarized data in our variable data binarized, and then we are printing our binarized data. Okay, this was your binarization process. Next process is mean removal, and first we are printing our mean of data, and standard std is representing your standard deviation. So we are using function mean and the function std, that is standard deviation function, and we are applying these function on our input data. These values are before applying mean removal. Next we are removing mean using your scale function, and after applying that function, we are again printing your mean and standard deviation using mean and std function as before, and then you will get different values. We will see those values in our output. Next we are using scaling function. We are applying scaling function, and for that we are using min max scaler. So we have used that function of pre-processing module, and then we are applying fit transform function for organizing our data for printing, and then we are printing those scale data on our console. So this is your variable which is representing your scale data. Now our last process is your normalizing. So for normalization, we are using normalize function of pre-processing module, and for that we are passing here as an argument our input data and norm, that is your norm, that is representing your normalization type. That can be either L1 or L2. So for applying our L1 normalization, we are passing here L1 as an argument, and for applying L2 normalization, we are passing L2 as an argument, and then we are printing those normalized data on our console. So these are the variables, and we are printing them. Okay, now let's run this program. Now see this output. This is your binarized data. So see, here are data containing either 0 or 1. That is your binarized data. Okay, now next we have applied mean removal. So this was your mean and standard deviation before applying mean removal, and this is your mean and standard deviation after applying mean removal process. Now see here, standard deviation values are 1 and your mean values are closer to 0. So we have applied here mean removal process. Next, this is your min max scale data, and next your last process was normalized data. So that is your L1 normalized data, and that is your L2 normalized data. So for these are the output, and we have applied all the 4 process of pre-processing our data, and this process we always use in our algorithms. So that's it.